Hello everyone, welcome to PE Academy, and in this video I'm going to be showing you the difference between elements, node, junction, branches, loop and mesh. So understanding the difference between all this will be of help whenever you are dealing with circuit analysis. So before we get into this video, if you are new to this channel, PA Academy, and that you are yet to subscribe, please click on that subscribe button. It's absolutely free to subscribe to this channel. And if you enjoy content under engineering, drawing and electronics and electrical topics, please do make sure you also subscribe. So the first one we are going to be looking at is elements. So when we say elements, it simply means what? It says these are basically electrical components in an electric circuit or network. An example we have is, for example, we have a resistor, the battery, maybe like your capacitor, and so on. So now let me show you. Now let's say we have a simple circuit like this. And here we have our voltage source, or you can call your battery. So here we have a capacitor. Now all this is let's call this is R1, let's call this R2, and let's call this R3. This is our voltage source, and then this is a capacitor. Now you see all these things are what we refer to as elements. You can see they are basically electrical components in an electric circuit. So all of these components are what we refer to as elements. So if you have a circuit and you hear the word elements, this is what we are talking about. So don't mistake it when we are dealing with don't mistake it with the one you find in chemistry, where the hydrogen, helium, lithium. That's not the one we are talking about here. So that is it for elements. Now let's go to the next one. That is number 2, which is node. Node. So the definition for node is what? So call it that this is a point of connection. So this is a point of connection between two or more circuit elements. Now I'll also use this circuit to explain what a node is. Now we said that it is a point of connection between two or more circuit elements. Now we already know what element is, which is quite alright. Now this point here is a node. Why? It is connecting what? Two or more circuit elements. Now this node, this point here that I just said is a node, is connecting this voltage source and this resistance, this resistor here. That makes this point a node. Is that clear? Now this is also a node because it is connecting how many? 1, 2, 3. And remember the definition, it says what is a point of connection between two or more. Now this is a point of connection between R1, R2 and R3. So this is also a node. Now this is also a node. It is connecting what? R2 and the capacitor. So let's call it C1. It is a node. Now another thing is this. If you look here, this part here, we cannot call it a node. We cannot also call this a node. But if you pick it together like this, it is a single node. I hope that is clear. And the reason is this. If we are to withdraw this diagram, we can also have it like this. So here this will be our voltage source. And then here we have. So now instead of coming like this, we can have everything coming to meet at this point. So you can see. So we cannot, there's no element here that we can say that, okay, this is a node, that we can call this a node. So this entire point like this is one node, is another node. So in this circuit now, if you are to write out the nodes, so if you are to say the nodes, so let's call this point A, B, C, and then this entire one, let's call it D. So the node in this circuit is point A, B, C, and then this together D. Those are the nodes in that circuit. So that is what we mean by node. Is a point of connection between two or more circuit elements. All right, so let's look at the third one. So the third one is what? Junction. Now, when we talk about junctions, it's what? A junction is a point of connection. Now look at this, between three or more circuit elements. Now I hope you're able to get the difference between a junction and a node. Node is between two or more, while junction is between three or more. So now let's come back to this circuit. If you are to pick the junction here. Now in this circuit we only have what? Two junctions, and that is this point B and then D as a whole. Now point B is connecting R1, R2 and R3. You can see three or more. So 3, that makes point B a junction. Point D is connecting the voltage source R3 and the capacitor. That makes point D, as it is like this as a whole. It also makes it a junction. So that's the difference between a junction and a node, and that explains that. So now let's look at the third one. The third one we are having there is, okay, now the fourth one rather, branches. So when we talk about branches, so branches is defined as, so a branch is defined as a path between two nodes. So if you are finding value in this video, please give it a thumbs up. So a path between two nodes. Now let's look at this. Now basically, when we look at branches, for you to identify the branches, the simple thing to note is this: that number of elements is also equal to the number of branches. This is number of branches. So that means in a circuit, if you have 5 elements in that circuit, definitely you are going to have 5 branches. I hope that is clear. If you have 2 elements, like I said, these are elements 1, 2, 3, 4, 5. So we have 1, 2, 3, 4, 5 elements in this circuit. Now that means we are going to be having 5 branches. And look at it. It said is a path between two nodes. Remember, this entire one like this, we've picked it as one node. Now, so between here and here, we have a branch because we have one element here. It says a path between two nodes. A path between two nodes. So between here and here is a branch. Here and here is also a branch. From B to this point is also a branch. Here is also a branch. So I hope that is clear. Say what is a path between what? Between two nodes. Now it's also important to note that. So let me clean this off first, and let me explain something. So if you have a circuit like this, now we cannot call from here to here a branch because there is no element in between them. I hope that is clear. So once there is no element between them, we cannot refer to it as a branch. Maybe, for example, you have a short circuit somewhere here. We cannot call this point to this point what? A branch. I hope that makes sense. If you do, please let me know in the comment section below. So let me join those lines back. So far we've looked at 4. So let's look at, now we already have 2 more to look at, which is the loop and mesh. Alright, so let's continue. So that is the 5th one, which is loop. Now I want you to pay attention to this very clearly. I want you to pay attention to this very clearly, because if you can understand the difference between this loop and mesh and generally everything, it will make it easier for you to understand when we start looking at mesh analysis, super mesh, northern theory, and Elder theorem and analysis. So now let's look at a loop. When we talk about a loop, it says what? A loop is defined as any closed path in a circuit. Any closed path. Look at this. any closed path in a circuit. Now I'll still be using this circuit to explain the concept of loop and mesh. Now look at this. So let's for explanation purpose, let me call this point D. Let me call this E and then F. Let's just separate it like that. Remember earlier I picked it together as a single node, but let's separate it for so I can explain this loop properly for you. Now if you look at this circuit, if you start from this point A, which is a node, A is a node, it says it's any closed path in a circuit. If I start from point A, if I decide to move clockwise, let's use clockwise position from A to B, from B to E, from E to F, back to A, that makes A, B, E, F a loop. I hope that is clear. That makes it a loop. So if you are to write out the loops in this circuit, now we have the first one we're having here is what? Is A, B, E, F. Is a closed path because I'm starting from A, I'm going around a closed path and coming back to that point A without going back to a particular node more than once. I started from A to B, down to E, F, and back to A. That makes what? A, B, E, F, A, B, E, F, and back to A. It makes it what? So let me just add the A. So we call it a loop. It is a closed path. A closed path. Now, if you look at it on this side, if you are to start from B and we move in a clockwise direction, so we will see that from B we move to C, D, E, and back to what? To B. So that makes B, C, D, E, B is also a loop. Are you clear? Now let's look at another one. We also have another loop in this circuit, and that loop is what? The entire circuit itself. So if I should move from A to B, C, D, E, and F, and back to A, is also a closed what? Is also a closed path, like this, from the outside. Is also a closed path. So that will be what? A, B, C, D, E, F, and back to A. So that means in this circuit now we are having what? 3 loops. 3 loops. So depending on the circuit you're given, you can have maybe 3, 4, or even more than. But if you can understand how to pick it, then you won't have problem in identifying the loops in any circuit. Now this is for loop. Now let's look at that of mesh. So for number 6, mesh. So now you define mesh as what? So it is a closed path. It is a closed path. Okay, let me come down a bit. For mesh, it is a closed path in a circuit, but do not contain any other parts in it. Now the difference between a mesh and a loop is what we are having here. Now a loop is any closed path in a circuit. A mesh is also what? Is a closed path in a circuit, but do not contain any other parts in it. Now let's come back to this circuit. It says that what? It is a closed path but do not contain what? Any other parts in it. Now if you look at A, B, E, and F, it is a closed path and there is no other part in it. I'm still going to explain it. So that makes it that what? A, B, E, F is a what? Is a mesh. I hope that is clear. A, B, E, F is a mesh. Now if you also look at it on the other side too, B, C, D, E, and B is also a mesh, because in this part like this, there is no other part within this B, C, D, E, and back to B. There is no other part, so that makes it a what? A mesh. So that is what? B, C, D, and E. So let's come, and then we come back to B. So from this, it comes back to A, like this. So this is a. Now let's look at this. Let me now explain where the key difference when you are comparing it with the diagram directly. Now look at this part: A, B, C, D, E, F, and back to A. you can see that it's also a closed path. But within this closed path, A, B, C, D, E, F, and back to A, we have what? Two other paths in it. If you are moving from here like this, we can also move from here like this. We can also move from here like this. So with that A, B, C, D, E, F back to A, we cannot call it a mesh. That is the difference between a mesh and a loop. When we are looking at a mesh, it said what? It is a closed path in a circuit, but do not contain any other path in it. So A, B, C, D, E, F, and back to A, there are two other paths within that circuit, between this part like this, and which is this one. We have one part here, another one here, in the entire circuit. So that means A, B, C, D, E, and F, we cannot call it a what? A mesh. Rather, we'll call it a what? A loop. But if you look at A, B, E, F, and E, you can refer to it as a mesh. You can also refer to B, C, D, E, and B as a what? As a mesh. So with that now, I hope you've gotten the difference between elements, node, junction, loop, and mesh. So before we go, if you have any question, please leave them in the comment section below. And this video is just more like an introduction to what we are going to be looking at in subsequent video, because I'm still going to be looking at mesh analysis, super mesh, nothing, Thevenin, and every other thing. So before we get there, I want you to really understand some of these basic things, because these are some of the terms that we are going to be using when we start solving questions under mesh, super mesh, and every other thing. So thank you very much for watching. If you have found value, please give it a thumbs up, and do make sure you share this video with your colleagues. And like I said earlier, if you have any question, leave them in the comment section below. And with that, I will see you all in another video. Thank you.